welcome to our discussion on clutches, bands, and one-ways. This is the introduction to these elements, and we're going to go through each type of these elements, and hopefully when we get done with it, we should be able to, disassemble and reassemble and analyze the condition of the various components in an automatic transmission, clutch, band, or one-way. So starting off, a term that's actually been used a lot here recently is an element, because in the old days they used to name them with pretty specific job titles in a sense. Back in the days of 3-speed transmissions, you would have a forward clutch, you'd have a reverse clutch, you'd have an overdrive clutch, a 2-4 band, meaning it'd be used in second and fourth gear. But with the number of gears that we have nowadays, the combinations lead to clutches having jobs in more than one gear. So they tend to call them element A, element B, element C, and so on until you name all the different clutches, bands, or one-ways. So an element is either a hydraulically or a mechanically operated component that its sole purpose is to drive or hold a planetary component. That's all they ever want to do. That's what they're connected to. Now you will have series operation where say an intermediate clutch is applied to hold something, and that intermediate clutch is holding an intermediate one-way. But if you keep going down the list, that intermediate one-way is ultimately going to be holding, say, a reverse sun gear. So they're always going to end up with a planetary component. That's the whole purpose of a clutch, band, or one-way. So hydraulically controlled components are going to be the clutches and bands. So we're talking about the multi-plate clutches and the bands, like in the transmissions that we're doing now, the big band that came out after the pump, that's the 2-4 band. Now mechanically controlled components, those are going to be the one-ways. And there's 3 different types of one-ways that are going to be used in automatic transmissions. But those are not going to be turned on hydraulically. They're not going to be activated by the transmission control module or any solenoids. They're actually activated mechanically. So whenever there's torque applied and there's counter rotation to their action, they'll lock up. And with the one-ways, their operation is really dependent on torque input to the system and whether or not the vehicle is accelerating or coasting too. So you have a one-way involved in, let's say, 4th gear. You can give it gas, the engine will rev, it'll catch that one-way, and you can accelerate. But when you let off the gas pedal, it's not like in a manual transmission. The engine will actually idle down, but you'll still be able to coast. And it's just like riding a bicycle with, while pedaling you can accelerate, but you can stop pedaling. So the first thing we have is our clutches, and this is going to be our multi-plate clutches. So clutches in automatic transmission are multi-plate units that use multiple interlaced clutches and steel plates. And this is going to be 95% of the time where you're going to have independent clutches and steel plates. So the clutches can either be a holding or a driving element. And holding clutches will usually have the steel plates splined to the case of the transmission. So there won't be any discrete drum in most cases, but the housing of the transmission will actually have splines for the clutches to lock into, much like the I think it's the reverse clutch in these, the low reverse clutch in the 4L60. So driving clutches will be housed inside a rotating drum, and that drum will be able to, it'll spline to something or it will lug into something, but it eventually is going to get power from an input shaft, and it's going to give power down to a planetary component. So both holding and driving clutches will be, attached directly or indirectly to a planetary component. So here's a quick exploded view. In this view right here, what we have is this right here is the input shaft of the transmission. Okay, and then this is a drum, and this just so happens to be the forward clutch drum. In that forward clutch drum, let's talk about the clutches. We have these light blue ones, those are the steels. Okay, and the steels are the ones that are going to be splined. There we go, look at that, look at that. The steel plates are going to be splined to the actual drum, because if you, how they have it drawn here, there's a lug there, there's a lug there, and those lugs are going to be lugging on or splining to these components in each one of those. So those are the steels. Now the light green ones, those are the clutches. And the clutches are going to have splines on the inside. See if I can get this full word out before it gets too small. There we go. So those are the clutch plates. And the clutches are actually going to spline to a component called the hub. Now it's not drawn in this illustration, but if we see there's actually teeth on the inside of the clutch plates, and every single one of them has teeth on the inside. The steels have teeth on the outside. And if those things are just sitting there next to each other, there's going to be a steel, a clutch, a steel, a clutch. If there's no pressure against them, then they'll be able to slide past each other, and that means that that clutch is not engaged. And that hub is going to go down and engage each one of these. Now, mind you, this thing is it's exploded out, and it looks like it's probably across about 18 or 20 inches. But when it's all assembled, it's probably going to be, 7/8 of an inch thick, and they'll just be there next to each other. So the other components we have in this thing is we've got a return spring, and that return spring is there to return the piston. Now this piston has seals. It has a rubber seal on the inside, and it has a rubber seal on the outside. And the side that we're seeing right now is where hydraulic pressure is applied. And that hydraulic pressure is going to push that piston in this direction. When it does that, it forces this steel against that clutch and against the steel and clutch, and then eventually it's going to get up here to this purple one, which is the pressure plate, and it's going to push against the snap ring, which is locked inside the drum, and it's going to compress all those clutches and steels together. The friction is going to build up, and eventually the steels will be driving the clutches, which will then be driving the hub in this situation. So there we go. All right, so the clutch and steel plates, the clutches, within the clutch, you usually have a friction material applied to both sides. Now that is not the case in every single transmission. Some clutch plates might be better described as internally splined plates, because they'll have clutch material on one side and steel on the other. But I'd say 95% of the time, it's going to be clutches are going to have the friction material applied to both sides. Now steel plates, if we look on the steel plate over here, it's just that. It's just a steel plate that's been stamped into a shape, and they have, it's just a steel surface on both sides. Now, like I said, same thing with the clutches. Steel plates 95% of the time are going to have steel on both sides. However, there are situations where you'll have steel plates, which would be better represented as calling them externally splined plates, because they'll have friction material on one side and steel on the other side. So these are some clutch plates here, and I'll be disassembling a clutch so we can get a closer look at these things. But the material that's applied here, it can be paper, it can be a carbon fiber based stuff, it could be carbon Kevlar, but that material right there is what they use to tune the friction, the coefficient of friction on the clutch, to determine how it's going to apply and how much torque it's going to hold. So we have these clutch plates and the steel plates. All right, so the clutch piston and drum. Clutch pistons, they're the movable hydraulic component. So if we look in this illustration here, we have this aluminum disc, and it's got a hole in the middle, and it goes down inside this drum. Now this drum, in the bottom part of it, in this bottom section, right where I've drawn it, all the way around it, that's a smooth surface, and the piston goes into that, and the rubber seal presses on the outside. And in this drum, there's a seal on the inside. There's a rubber seal that when you put that piston in, it pushes on the inside of the hole of the piston right here, and it creates a hydraulic seal. And the transmission, whenever it determines to turn this clutch on, in this transmission it'd be third and fourth gear, hydraulic pressure is actually fed from the center of the shaft into this whole area, which causes that piston to move. Now this piston is made out of aluminum, but there are pistons that are made out of steel, and there's pistons that are composite. It'll be steel and aluminum together. For whatever reason, they decided that was the best thing in those applications. So pistons are held within the drum, which act as a housing for the pistons and clutches, and the pressure is fed into the bottom behind the piston, and that causes the clutch to apply. Now the holding clutches, so that would be what I just described, would be, usually on a driving clutch, a clutch that's actually going to be spinning inside a drum. Now if it's a holding clutch, the piston doesn't rotate. It's actually located somewhere in the housing or in a support that is bolted or snap ringed into the housing. Those are going to have pistons that are located in that housing or in the transmission case. They're not going to rotate. So the piston's bore where it sits is integrated into the housing or that support housing that it goes. So, and like I said, rotating clutches will be housed within a drum. Now return spring, so the component that pushes that piston back. So when the piston is done applying, and let's say we shift out of that gear and that clutch isn't needed anymore, the hydraulic pressure is released. But we need something to push the piston back. It's kind of like a jack. So when you jack a car up, what causes the jack to return to the bottom? Well, if the weight of the car is on it, well, it's the weight of the car that pushes that thing down. But once the weight of the car is off, some jacks, they won't return all the way, so sometimes you have to open the valve more, or you have to push down on the jack to get it to return to its bottom position. Well, same thing here, but even more important is that we don't want to go from one gear to the next to turn off a clutch and that clutch still be applied, because what will happen is that you'll actually get a drag. If that's a driving clutch, you'll be trying to drag it into one-to-one if another driving clutch is applied. Or if it's a holding clutch, let's say it's supposed to turn off and then the next clutch is going to be a driving clutch that turns on, you'll actually be locking the transmission down because you're trying to drive too many pieces at different speeds, and it'll cause it to bind up. So the way that they return the piston, there's really three different methods here, primary methods. This first one here, this is called a Belleville spring. So that Belleville spring, this one here, is basically a big disc of spring steel that has a cone shape to it. You can kind of see these little fingers are bent up. When the piston is applied, it's actually going to push on the outer rim here from the bottom. The inner rim is going to be supported by a snap ring, and when that piston goes up, the spring deforms much like a diaphragm spring on a manual transmission clutch. So the next style is just a big single coil spring. And it's pretty simple. This top part is going to be retained by a snap ring. The bottom part is pushing down against the piston. And when the piston is applied, it's going to compress the spring. When the piston's hydraulic application pressure disappears, the piston's return spring pushes the piston back down into its rest position, releasing the pressure from the clutch pack. And then the last thing is a set of parallel springs where all these springs are just working in unison to return the piston back down, just like the other two. So we have a Belleville spring, a single spring, and a parallel spring pack like that. So piston seals. The piston seals, there's four primary types, and they can be used in different applications. Two of them are similar, but it's really the construction of the piston that differentiates them. So the first style is an O-ring style, and that's this one right here. So this is our O-ring style. And if you look at it, it actually has a round cross section to it. So if we were to cut this O-ring, it would actually have a round shape left over on the face of that cut. So that's our O-ring. The next style is the square cut seal. You see they've cut this seal, and it has pretty much a square cross section face on it. Then we get down to the lip seal. Now, before we move to the lip seal, let's talk about these two. These two are non-directional because their shapes are symmetric. So an O-ring and a square cut seal, there's no top or bottom to them. So you can install it one way or flip it over and it work exactly the same. Now that we're down here to the lip seal, if you look at this seal, and they talk about two different designs, but really we're just looking at this here. This piston is, we'll say, is positioned upside down, so the hydraulic pressure would actually be on the top of this piston, pushing it down. And the idea is that inside a slot machined into the piston, so let me draw a part of the piston. Here we go. Here's our slot on the piston. There, okay, so there's our piston. Hydraulic pressure comes from this side. Now, because this piston and piston seal are inside a housing, this hydraulic pressure comes inside here, and the idea of the lip seal is that it has a very quick movement, it has very little drag against the piston, but it has an excellent sealing component, or an excellent sealing characteristic, because this hydraulic pressure gets into that lip seal and it pushes it against the wall. When it pushes it against the wall, it causes it to seal better. Because of that, the lip seal design, lip seals are directional. If you were to install the seal upside down, let's say this one over here, we put it upside down so the hydraulic pressure is coming from this side, all it's going to have to do is put a little bit of pressure against this seal, and it's going to fold it back, and then the hydraulic pressure will leak out. So lip seals are directional, O-rings are not directional, and square cut seals are not directional. The last style is this one here. Notice we've got this black ring around the outside and then a black ring on the inside. And they're both attached to the piston. So this is what's called a vulcanized or a bonded seal piston. So this one actually has the rubber molded onto the piston itself, so you can't replace this seal separately. So each one of these, the O-ring, the square cut seal, and the lip seal, they're kind of like piston rings and pistons in the engine. You can take the rings off and replace them. But when we get to the bonded piston, you can't replace the seals off of that. You have to replace the whole piston. Manufacturers use this because it's really strong design. It's cost effective because it makes for quick assembly. They just have somebody manufacture a stamped steel piston. They bond in the seal on the inner and the outer, and they don't have to put piston seals on the piston before they put in the drum. They pull the piston out of the package or whatever shipping method they use, and then they just drop that thing down in the drum, and boom, they're done with it. So don't forget the O-ring, the square cut seal, and the lip seal. Then there's the bonded piston where you have to replace the whole thing. All right, again with the exploded view here, so the pressure plates, let's talk about the pressure plate and apply plate and wave spring. So we see this first one right here, which is called the pressure plate. It is going to be at the top of the drum, and it's usually going to be the thickest plate, and it's because all the force from the bottom clutches and steels are pushing up against it. It needs to be thick to keep those clutches from distorting. You don't want them to dish. And it's a nice thick plate to keep that from happening. And the pressure plate goes against the snap ring, which retains the clutches and steels. The next one, which is the apply plate, which is not shown here, but the apply plate will oftentimes go down to the bottom of the clutch pack. And they'll use it for various reasons. Sometimes it's used depending on the type of return spring inside the clutch drum. So the apply plate will go down to the bottom, okay? And the apply plate is just like a pressure plate in that it's a thick plate, but because of, in most cases, it's because of the return spring. It's usually a Belleville spring that's pushing up, and it needs a place to pivot on, so they'll design an apply plate and piston combination that will allow that apply plate to move up and down in a nice linear fashion. The last one is a wave spring. A wave spring will also go down in the bottom of the clutch pack. So here we go, we got a wave spring. And the reason for a wave spring is it's usually there to control the application force to help smooth out the application of that clutch, or soften it, they say. A common thing to do whenever it gets to high performance is to take the wave spring out and change the pressure plate so you can put in more clutches and steels. And because there's no wave spring, then it will hopefully apply that clutch much more firmly. So pressure plate, apply plate, and wave spring. Here we are at the table. We have the clutch out of our transmission, the 4L60, and this is the reverse input clutch, and you can see it's still fully assembled. Inside it we have the clutches. There's also the steels. Of course, the top is the pressure plate. There's our return spring plate, which with all those holes, those are where the springs are located. All the parallel spring pack is located underneath there. And then down below that is the piston, and of course it's got the piston seals on it. I'm going to be using a clutch return spring compressor to remove and disassemble this clutch pack. So the first thing that we need to do is remove the snap ring inside the clutch. So we see the snap ring right there. Let me zoom in a little bit. All right, so we see the snap ring right here. And what I'm going to do, let me get some light on it, is I'm going to put my screwdriver underneath. I'm just going to lift it up, and then I can pull it out the rest of the way. And that's usually how you're going to remove the snap rings. Now the snap rings in most transmissions are going to be clutch specific because the diameter and then the thickness is going to be specific for this clutch drum and clutches. Now from there, all I need to do is just lift up on the clutch plates and then pull them up and out of the clutch drum. So the first thing you want to do is pull the clutches out, and you want to flip them over, and you're going to just take a look at the general condition of these things. And we can see that we've had some heating in them, which is perfectly normal with this transmission. But we've got right through here, you see that little dark spot there. That dark spot indicates it's just had a little bit of heat, but nothing serious. So this clutch is actually in good shape. We've got these little holes there to help evacuate the fluid that gets stuck in between them, just to make the shift a little bit more reliable and consistent. So we have this plate that sits on top of them. You see that we have all these different thicknesses. We've got this very top one right here, which is the thickest one, and that's our pressure plate. And we have our clutch. Notice it's got clutch material on both sides, and it has the internal splines on it. And we have a steel, and this steel's got splines on the outside, and it's steel on both sides. And it just continues that way all the way down. This one here happens to have 1, 2, 3, hold on, let me count. There's 4 clutches and 4 steels, 1 pressure plate. And then on this last one here, we have a spring. Now this isn't necessarily a wave spring, but this is actually a Belleville spring that acts just like a wave spring. So this one isn't flat. If I were to put it down on the table surface and just push on the edge, we see it lifts up, and it performs the same function as the wave spring. So we've got it apart. Now the next thing I'm going to do is position it over in the clutch return spring compressor, and I'm going to compress the springs and then remove the snap ring with a pair of snap ring pliers. So let me get set up for that, and I'll bring you back. All right, here we are over at the clutch return spring compressor. This is a table mounted model. You'll be using probably the free-handed model. And what I'm going to do is position these legs here down onto that return spring plate. So I'm going to drop that down inside there. I'll lock it, and I'm going to start to rotate. And if you watch this area right here, you see that area there? It's going to slowly lower down. So let me see. Yeah, let me get this far. There we go. So watch this area right here. Now I don't need to compress this thing all the way down. All I'm doing is just compressing it to release the pressure off the snap ring and to lower the snap ring lock tabs below the snap ring. So for me, it had a total of about 1, 2, probably 2.5 turns, probably 2 1/4 turns, and that was it. Now from there, I'm going to use my snap ring pliers, and I'm going to remove the snap ring. Just expand it. Oops, missed it. Hold on, let me try the other ones here. Then bring them over here. Oh, dropped them in the box. All right, so let's try this one here. There we go. Whoops, and it just snapped off like magic. So there's our snap ring, our return spring retaining ring right there. and then all I need to do is release it. So if you see as I back this thing off, that return spring comes up much higher than it was before because the springs are now fully extending. All right, so I've got it fully released. Move that out of the way, and I can lift up and remove my return springs. Okay, so here's my return springs. You can see all the little coil springs inside there. And then from there, on this piston, you normally can just grab the piston and pull it up out of here for this reverse input clutch. So you can see I'm just going to pick it up, pull it right on out. And then we see down inside the drum, down inside there, and we see our piston. We've got a rubber seal here on the outside. Okay, we've got a rubber seal there, and then we have a rubber seal on the inside. And we'll be taking these off and getting a much closer look at them. All right, we're back on the table, and we have various components here that we're going to take a closer look at. So the first thing we've got is the piston that came out of the reverse input clutch, and it's got its seals on it. And this is our low reverse piston of the transmission. This one actually has 3 seals on it. It's got a seal here, seal there, and a seal right here. And we can get to see the different types of seals. So I don't have a bonded piston yet. It's actually in the last clutch, but we'll see that when we do it. But we have 3 different types of seals here. I've got an O-ring seal here. We have the lip seal, and then we have a square cut seal. What I'm going to do to make it more obvious, hopefully, is get a much closer shot on these things, is I'm going to take these seals, or one of each, and I'm going to section it so that we can actually see get to see the actual shape of it. All right, so if I take my knife here, I'm going to cut a small piece of it out. I'm going to cut another piece so I can set it underneath the microscope. So we've got a little piece there, and this is for the lip seal. And I'm going to do a square cut seal the same way. Of course, it's called square cut. It's rectangular, but that's fine. We're not too worried about specific shapes. And then we have an O-ring seal. And then we'll just portion out that piece there. Now we're over here at the microscope, and I've taken those pieces that I sectioned off each one of those types of seals, and we see the first one here, which is the O-ring seal right there. You can see that it's literally just a round seal. And that's the shape of it all the way around the piston seal. The second type is the square cut seal here, and you can see it's not technically square, but it does have square corners, so they're each 90-degree corners of rubber. And of course, remember that the O-ring seal and the square cut seal are non-directional. They can be installed in either direction, upside down or right side up. Then the last one here that I have is the square cut seal. Now this is a much more dynamic seal because it doesn't require so much external static pressure, meaning whenever this piston was in the bore that it was in, say the square cut seal or the O-ring seal, there's a lot more pressure against the wall of the bore to seal the piston. With this one here, the lip seal, we can see because it's got that shape to it, this undercut, and then of course the lip right here, hydraulic pressure happens on this side, and what happens is it causes it to push it out and seal better against the wall. So if we install this lip seal upside down, let me see if I can flip it over. There we go. All right, so let's say we install this lip seal upside down. And now the pressure's on this side. That pressure is just going to go up, and then it's actually going to fold that seal back, and it's going to leak. Now, it does lead to another, I wouldn't call it an issue, but another characteristic of lip seals is that you can't just push the piston into the bore. You actually have to have a tool or usually a seal protector that what it's going to do is all the way around the piston, it's actually going to fold that lip in so that it can go down into the bore of the drum. And it's going to be almost exactly like a piston ring compressor. It's going to cause that lip seal to fold down so that it will slip down into the drum, because this one here, because it's got such a long lip on it, it tends to be there tends to be more chance of damaging it. And a good rule is once you get that piston in the bore, you should be able to grab it and rotate the piston around very easily if it's a lip seal. Now, if it's an O-ring or a square cut seal, it's going to be pretty difficult to rotate in most cases. So again, we have our O-ring type seal here, and then we have our square cut seal, and then this last one is a lip seal. It is directional, it's dynamic, and it also requires care when installing it back into the bore so that we don't cut it so easily. Now, I'm not saying that these two over here don't run the risk of cutting or being cut during installation, but it's much less likely.